Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in these two examples in this video, we'll take a look at hyperbolas that have been translated on the graph, either horizontally and or vertically. And really, the procedure we used for the last two videos will stay the same. Once we know what the center is, we'll follow all the same approaches. So first thing here is I know it's written in the form x squared minus y squared equals 1. So I know that this is one that opens left and right. It has a horizontal transverse axis. So I know that it's going to open like that. The center is -3, 2. H is -3 because that's what's really being subtracted from x there. And that should be -2. K is -2. Y plus 2 is the same as y minus -2. So I've got a center at -3, -2. I'm going to put that on the graph. From the denominator under x squared, I know that a squared equals 4. So a equals 2. That means that the vertices are going to be 2 to the left and 2 to the right of that center. So one of them is at -1, -2, and the other is at -5, -2. And I got both of those by subtracting and adding 2 to the x coordinate of the center. Now to make the box, I need to know what b is. B squared under the y squared term is 9. That leads me to b equals 3. So when I go to make my box, I'm going to go up 3 from the center and down 3 from the center. And that's where I want to make the box to draw my asymptotes. Like that. Let's draw the asymptote and finish drawing the graph. Now, that one has slope 3/2. Underneath the y, we've got b equals 3. Underneath x, we've got a equals 2. So that's the slope. But it goes through the point -3, -2. So I know that the slope is 3/2, but I want to write it this way. So notice what's happening there. I'm taking those two expressions from the numerator and I'm bringing them over to the equation of this asymptote. And we could see, for instance, we can tell that everything's good there. I'll edit this out in a moment. That's how you find the equation of a line through a point, right? We know y minus y sub 1 equals m times x minus x sub 1. Right? We've used that for the form of an equation of a line. So I'm just putting in y minus -2, x minus -3. The other one goes like that, and that is y plus 2 equals -3/2 times x plus 3. I've got everything I need to sketch the graph. The first branch to the right should look like this, and the second one something like this. Again, just a rough sketch. You could get more precise by finding intercepts, etc., but here we're not really worried about that. I do need to find the foci. C equals the square root of a squared plus b squared. C equals the square root of 4 plus 9, which is 13. I did this one earlier. It's still on the screen. 3.6. So we're going to go 3.6 to the right and the left of the center. 1, 2, 3.6, 2, 3.6, like that. And what we're doing is we're starting at -3, and then we're adding and subtracting that 3.6. So the foci, the exact coordinates are -3 plus root 13, comma, -2, and -3 minus root 13, comma, -2. Using the fact that the square root of 13 is about 3.6, -3 plus 3.6, that's 0.6, and -3 minus 3.6, that's -6.6. And if you look at the coordinates on the graph where I drew them, you can see that that lines up with what we just found. All right, let's try one more. This time we'll do one that opens up and down. We've got y plus 4 squared minus x minus 2 squared over 16 equal to 1. Remember that if a denominator is missing, it's really a 1. We just don't bother to write that. Center. X first. Even though the y, we see the y first, you've got to write down the x coordinate first, and that's going to be 2, and then -4 for y. H is 2, k is -4. A squared equals 1 means that a equals 1. We're going to move up and down by 1. B squared equals 16. B is equal to 4. That's going to be left and right from the center. And let's start there. By the way, this is the same approach we use for ellipses. Over 2, down 4, put the center on the graph, move 1 in the y direction in both up and down, move 4 horizontally for the constant under the x squared term. And if this was an ellipse, we would just connect those dots. But instead, that's going to help us to figure out where our asymptotes are. And again, we know that this one opens up and down. Like that. See, we want the vertices, so those were 1 above and below our center. The vertices were at 2, -3, add 1 to y, and 2, -5, subtract 1 from y. The domain, all real numbers, we've got arrows to the left and the right. The range starts at -infinity, goes up to where it turns around at -5. Begins again at -3 and goes to infinity. Let's see, all we're missing are the foci. C equals the square root of a squared plus b squared. That's the square root of 17. That's going to be just a little bigger than 4. Square root 17. 4.1. So that's 4.1 above the center and 4.1 below the center. Those are the two foci. Their coordinates, we're adding the square root of 17 and subtracting the square root of 17 from the y coordinate. So 2, -4 plus root 17, 2, negative 4 minus root 17. And if we approximate that as 4.1, 2 comma 0.1, and 2 comma negative 8.1. Oops. All right, that's it for that graph. When we come back, we'll take a look at what happens when it's not in any of these forms that we've seen so far. We'll use completing the square.